First week of development. Before getting into the first week of development, we need to understand what are the events that occur before the first week of development. So, before the first week of development, we have gametogenesis. In male, it is called spermatogenesis, which occurs in the seminiferous tubule of testis, and in female, it is called oogenesis, which occurs in the ovaries. Now, let's learn about the spermatogenesis. It is a process of formation of spermatozoa from the primitive spermatogonium, which is also called primordial germ cell. It begins at the time of puberty and continues till the life. About 300 million sperms are produced every day by the testis, which is a mixed type of gland. Mixed because it has both exocrine and endocrine function. As exocrine, it produces spermatozoa. As endocrine gland, it produces testosterone. Now let's see the mechanism of spermatogenesis. At the time of puberty, under the influence of follicle-stimulating hormone, luteinizing hormone, and testosterone, the primitive germ cell is converted to spermatogonium, which is then further divided to form spermatozoa. The phases of spermatogenesis are phase of proliferation, phase of growth, phase of maturation, and phase of transformation. If we look at this figure here, we can see that at first, spermatogonium produces primary spermatocyte under mitotic division, which is a equational cell division. Then, primary spermatocyte produces secondary spermatocyte by first meiotic division, which is a reductional cell division. So, secondary spermatocyte is haploid in number. Then, secondary spermatocyte produces spermatids under second meiotic division. And then after, spermatids produces spermatozoa under transformation. This process is also called spermiogenesis. Phase of proliferation. In this phase, the diploid spermatogonium divides mitotically to form primary spermatocyte without any change in the chromosomal number. It is because the mitosis is the equational cell division. Phase of growth. In this phase, the primary spermatocyte grows in size up to its maximum, after which it enters into the phase of maturation. After the maximum growth of the primary spermatocyte, it goes under first meiotic division and forms secondary spermatocyte, which is haploid in number. It is because the first meiotic division is reductional cell division. Then, once again, the secondary spermatocyte goes under the second meiotic division. But this time, the second meiotic division is the equational cell division. So, the number of chromosomes remains same and the spermatids are formed. And then, lastly comes the phase of transformation, which is also called spermiogenesis. In this phase, no cell division occurs, but the formed spermatids are matured to form spermatozoa. Changes that occur during spermiogenesis are formation of the acrosomal cap, formation of the neck, middle piece and tail, shedding of the most of the cytoplasm, condensation of the nucleus, and residual body phagocyted by Sertoli cells. Here, the different part of the spermatozoa are formed by different cell organelles, like acrosomal cap is formed by Golgi apparatus, head is formed by nucleus, neck is formed by centrosomes, middle piece is formed by mitochondria, and tail is formed by microtubules. Microtubules which also helps in the locomotion. This is all about the process, formation and maturation of spermatogenesis. Now let's come to the oogenesis. It is a process of formation of mature oocyte from female primordial germ cell called oogonia. It starts before the birth during intrauterine life and persists till the menopause. In spermatogenesis, we can see that millions of sperms are produced per ejaculation, but here in the oogenesis, only one matured ovum is produced per ovulatory cycle, along with some few polar bodies, which is nothing but a non-functional daughter cell of primordial germ cell that helps to get rid of unwanted chromosomes. Ovulatory cycle. It is a monthly rhythmical changes in the secretion of the female hormones along with the follicular changes, which has 4 phases: menstrual phase, follicular phase, ovulation, and luteal phase. Ovulation is the periodic rupture of the matured Graafian follicle and release of the matured ovum in the abdominal cavity and simultaneous maturation of the another oocyte on the 14th day of the ovarian cycle. Ovulation again has 2 phases, follicular phase and luteal phase. Follicular phase. It is a process of formation of matured Graafian follicle with secondary oocyte from the primordial germ cell under the influence of the follicle stimulating hormone. Now the events that occur during the follicular phases are: initially the primordial follicle is surrounded by flat epithelium. When the flat epithelium changes to cuboidal epithelium under maturation, then the follicle becomes primary follicle, which contains primary oocyte. Then the theca externa and theca interna develops. Theca externa means zona pellucida, which acts as barrier, and theca interna means connective tissue. Then, slowly, an antrum appears in the follicle and the follicle changes to secondary follicle. Secondary follicle further matures to form Graafian follicle, which contains secondary oocyte, which is then ready to be ruptured under the influence of the luteinizing hormone and release the ovum into the abdominal cavity. Luteal phase. About 28 to 36 hours before the ovulation, which is on the 14th day of the ovulatory cycle, estrogen level rises, due to which the positive feedback mechanism of the hypothalamus causes release and spike of the luteinizing hormone, which is also called LH surge. Now, under the influence of the LH surge, final maturation of the follicle occurs and the rupture of the Graafian follicle occurs to release the ovum into the abdominal cavity. Here, in the first figure, we can see that the follicle contains flat epithelium. So, this is called primordial follicle. Then slowly, in the second figure, we can see that flat epithelium changes to cuboidal epithelium. So, this is called primary follicle. Now, in the third figure, we can see that red colored zona pellucida appears. So, it is called secondary follicle. Now, secondary follicle slowly matures to form Graafian follicle by the appearance of the antrum. Oogenesis before puberty. As we know, oogenesis starts before the birth of the baby. So, the primordial germ cell starts to appear in the second week of development and oogenesis begins in the third week of development. Then, by the 6th week, the primordial germ cell migrates to the genital ridge, where it divides mitotically to form oogonia. Now, by the end of the 5th month, the number of oogonia increases to 7 million by division. In the 7th month, some of the oogonia enter the first meiotic division but do not complete the division and get arrested in the diplotin stage of the prophase 1 and forms primary oocyte. Then, by the end of the 8th month, physiological cell degeneration begins and the number of oocyte decreases to 6 to 8 lakhs. At the time of birth also, a female baby contains about 6 to 8 lakhs of primary oocyte in their ovarian cortex. Cell degeneration continues even after the birth and by the time of puberty, the number of primary oocyte decreases to 40,000. Then, during the puberty, in each ovarian cycle, about 15 to 20 follicles goes under maturation with their primary oocyte. Among them, only one attains the maturity. Now, oogenesis after puberty. At the time of puberty, under the influence of the follicle-stimulating hormone, 15 to 20 primary oocyte begins to mature, but only one attains the maturity. And this happens 3 hours before the ovulation in the ovarian cycle under the influence of the LH surge, where the primary oocyte completes its first meiotic division and enters the second meiotic division, but once again, it does not complete the division and gets arrested in the second metaphase of the second meiotic division. After the completion of the first meiotic division, primary oocyte is converted to secondary oocyte. Now the secondary oocyte only completes its second meiotic division if the fertilization occurs and forms 3 polar body and an zygote. If fertilization do not occur, then it only completes the first meiotic division and forms 1 polar body and 1 secondary oocyte, which degenerates after few days of ovulation due to lack of progesterone and estrogen, which is secreted by corpus luteum. So the whole process of oogenesis begins before the birth in the intrauterine life and continues throughout the reproductive life, that is between 11 to 15 years until the menopause. Now, what is menopause? Menopause is the complete cessation of the menstrual cycle that occurs at the age between 45 to 50 years in female. Menstruation begins at the age of 8 to 13 during puberty. Now, corpus luteum. At first, there are 2 types of corpus luteum. Corpus luteum of menstruation and corpus luteum of pregnancy. Corpus luteum of menstruation. If the fertilization do not occur, then the Graafian follicle forms a yellow vascular mass which is called corpus luteum of menstruation, which provides progesterone and estrogen for about 8 to 10 days that inhibits the ovarian cycle, and after that the corpus luteum degenerates and progesterone and estrogen level decreases, due to which menstruation occurs, and then again under the influence of the follicle stimulating hormone and luteinizing hormone, ovarian cycle repeats again. Now, corpus luteum of pregnancy. After the ovulation, if the fertilization occurs, then corpus luteum of pregnancy forms, which provides progesterone and estrogen up to the 4th month of the pregnancy, and after that the placenta is formed, and then the placenta provides progesterone and estrogen for the rest of the pregnancy. So the corpus luteum on the 4th month, it degenerates and is replaced by placenta. Now let's look at the mechanism of oogenesis and follicle development diagrammatically. As we know, the oogenesis begins before the birth, so during the intrauterine life, at first the primitive germ cell is converted to millions of primordial follicle under the mitotic division, which contains oogonia, that is diploid in number. Then the primordial follicle enters the first meiotic division but do not complete the division and gets arrested in the diploidine stage of the prophase 1 and forms primary oocyte, which is again diploid in number. All this happens before birth in the intrauterine life. Now, after the birth, ovaries remains in the inactive state until the puberty. Now, at the time of puberty, primordial follicle is converted to primary follicle, and the primary oocyte inside it 3 hours before the ovulation under the influence of the LH surge completes its first meiotic division and forms secondary oocyte and one polar body. Secondary oocyte is haploid in number because the first meiotic division is reductional cell division, and the first polar body is nothing but a inactive daughter cell that helps to get rid of the unwanted chromosome. During this process, the primary follicle grows and forms mature follicle, and then the secondary oocyte enters the second meiotic division. But once again, the second meiotic division do not complete and it gets arrested in the metaphase 2 of the meiosis 2. Then the ovulation occurs and the mature Graafian follicle ruptures, due to which the secondary oocytes are released in the abdominal cavity and the remaining part of the Graafian follicle forms corpus luteum. If the ovum gets fertilized, it forms a zygote and 3 polar bodies. Once again, the zygote formed here is diploid in number because it is formed by the fusion of the 2 haploid cells, that is male gamete and female gamete. All this process happens in the cortex of the ovary. Here in this figure of the ovary, in the cortex, we can see that at first the primordial follicle is converted to primary follicle, and then the theca cells and zona pellucida starts to appear and antrum appears, and it forms the mature Graafian follicle, which contains secondary oocyte surrounded by cumulus ovorus. Now, during the ovulation, the Graafian follicle ruptures and the secondary oocyte surrounded by cumulus ovorus is released into the abdominal cavity. After the release of the secondary oocyte into the abdominal cavity, the cumulus ovorus around it rearranges itself into the radial manner and forms a barrier which is called corona radiata. Corona radiata acts as the barrier for the secondary oocytes during fertilization, which is pierced by the capacitated sperm. Now here the remaining part of the Graafian follicle forms a yellow colored vascular mass which is known as corpus luteum. If the ovum gets fertilized, it forms the corpus luteum of pregnancy, and if the ovum do not get fertilized, it forms the corpus luteum of menstruation, which further degenerates to form corpus albicans. This is all about the oogenesis, and this is all about the gametogenesis, and these are all the events that occur before the first week of development.